Weather. As we know, Hurricane Milton made landfall as a Category 3 storm near Siesta Key, Florida. It then moved across the state and back into the Atlantic Ocean. More than 3 million customers were without power because of that storm plowing through there. Before, though, it made landfall, it did rapidly intensify into a Category 5 storm. There's been a lot of misinformation out there, Todd, about this storm. And just how fast it intensified. So you are here to sort of set the record straight for us.
Yeah, this has happened before with hurricanes rapidly strengthening. And we kind of call that a rapid intensification process. And so let's talk about it. Yeah, a lot of speculation. How did Milton get that strong that quickly? And it's all about science. All right, so here's what we're looking at. In the Gulf of Mexico, you see the red colors. That represents very warm ocean water. A lot of high oceanic heat content. The warmer the water, the higher the fuel for tropical systems to work with. So a tropical system's engine is the warm water. So anytime a tropical system moves on land, it weakens because it drops its engine, leaves it behind. Again, warm water is the fuel for any tropical system. Look how warm some of these ocean water temperatures were, and this is the track of Milton. It formed, again, kind of coming out of the Caribbean in the Bay of Campeche's southwestern Gulf, and then tracked right across the southern Gulf, close to the Yucatan, very warm ocean waters. And I want to point out this right here. You see this darker red? That represents the loop current. That's kind of today, but earlier, Milton tracked right over the very warm loop current waters. So if you remember, it did undergo some rapid strengthening because warm water is energy and fuel. That helped Milton get stronger, number one. Okay, but then it strengthened again as it went over this warm loop current water. But notice as it got a little bit closer to the coast, there's a little bit of not quite as warm. Main reason it weakened was because of higher amounts of wind shear. Let's talk about the wind shear. Now, when Milton was over the southwestern Gulf and down near the Yucatan, had very favorable upper level winds, not much shear at all. Hurricanes, tropical systems do not like any wind shear. They're actually fickle storms. Just a little bit of wind shear will kind of tilt them over and they'll start to weaken some. So had light winds aloft, warm oceanic waters. Those are the two main reasons that we saw Milton get quite a bit stronger, especially that warm Gulf of Mexico water. Also, we have what we call eye wall replacement cycle. And whenever it goes into a replacement cycle, you have a new outer ring that forms and it kind of takes the energy away from the initial one. So sometimes you'll see a weakening process. We saw that happen in between its strengthening. But once that hurricane reforms a new eye wall, it can then expand and re-strengthen. And so that eye wall replacement cycle is another factor that we saw with some of the strengthening of Milton. So again, we did see that rapid intensification, and then thankfully, once Milton moved inland and out to sea, now we're talking about post-tropical Milton, and it's going to move a little bit closer south of Bermuda as just a tropical low. So that kind of covers Milton. Again, a lot of speculation. It's all about the science in the ocean, in the atmosphere, the warm water, the light winds. That's why it strengthened. No other reason caused it to strengthen like that. Just throw that out there.